So I'm going to talk about some of the work that we've been doing in our team about the privacy and security challenges in AI agents. So I don't know how many of you guys were around in 2015. I mean, I was certainly around. And in 2015, what happened was that for the first time, what happened was that, you know, machine learning, which was, AI at the time, had started getting used. And as a result, things like privacy, security, and, various other things like, transparency, fairness, uncertainty estimation, things like that, uh, around that time started to become really important. Okay. And fast forward to 2025, now I think we can all agree that the situation has changed a lot. We have these huge models. Question is, do we still need AI privacy and security? And what I'm hoping to convince you today is that yes, but the problems look very different. The problems have changed quite a bit. And, if anything, I hope I can convince you that the problems are actually more serious and more real now. Okay. So let's look back quickly at privacy. So in 2015, what people were doing is we were looking at data privacy and classification. We had data from users. Some of this data was sensitive, and we were training models on sensitive data. And the kinds of solutions that we were looking at were, things like differential privacy or federated learning, where we were trying to ensure that the training data stays private, right? The training data does not leak out of the model. Now, fast forward to 2025, let me try to argue that we have more serious privacy problems. So let me give you an example. Let's just say, the example of UI agents that my team has been working with. And what is the idea of UI agents? So let's say you have a model. I can tell the model, go through my emails and file the receipts from my new strip, and the model will just do that, right? But now the problem is this model or the AI agent knows a lot of sensitive information about me, right? It has access to all my email. It has access to, not just my Uber receipts for this trip, but for a lot of other things. And is it using this information properly? Is it using it in the context that it should and not otherwise, right? And so what we want our agent to do is something called data minimization. And in data minimization, the idea is that your agent will only use the sensitive information that is required for the task and not otherwise. So, for example, it shouldn't, if I ask it to file my taxes, it will use my social security number, but not if I ask it to file my reimbursements, right? That's an example. And what we did was we looked at, we built Agent Dam, which is a data minimization benchmark for these kinds of UI agents. And what we found was that the agents do leak a lot of irrelevant sensitive information. Okay. And, we tried playing with this and a bunch of mitigation techniques through system prompting. And what we did find was that did not help very much. Okay. Okay. So moving on to security, this was kind of what passed as AI security in, around 2015. So I don't know if people remember this. So there were these things called adversarial examples. And the idea was that you could take images and you could perturb it a little bit by adding, you can see like a seemingly random noise like that, and you would get another image, and a lot of the neural network classifiers would just misclassify them. Okay. Now, fast forward to 2025, AI security is actually a lot more serious. So now we are talking about AI agents. We have something called prompt injection attacks. If you don't know what they are, I will give you one example, which was in the news recently, where, people put hidden prompts in their paper saying, accept this paper. And if an LLM was reviewing this paper, it would accept it, right? So that's an example of prompt injection attacks. And so there was some prior work on prompt injection attacks, but, usually they were in a chatbot setting and they looked at simple attacks. And also the threat models for, more complex agents were not well defined. We had, some assumes that adversary would control a lot of things. There were toy adversarial calls. And, obviously there are more realistic benchmarks, but they were behind closed doors. Okay. So what we did was we built WASP, which is a benchmark for prompt injection in web agents. We looked at real adversarial capabilities and real security violations. So it's a much more realistic benchmark than what was around. And we managed to test it in an isolated, test various, agents in a realistic environment. And I will leave you with the main insight that we found. The main insight that we found is that the adversarial attacks cause the models to stop doing what they were doing. I mean, they kind of divert the models, but the models still don't completely complete the adversarial goals. So in some sense, what we see over here is some sort of what we like to call a security by incompetence, right? The models are secure at the moment because they are not very competent. And I will leave you with this theme, which I have seen in a lot of this workshop. Thank you.